Okay, welcome to Optimal Stormwater Insider. This is introduction to GPT Rectifications with Hugh Williamson, with acknowledgement of Powell, production by Phil Lee, music by X-Ray Dogs. So, some things to look out for. Questions to ask about your GPT. Does your device remove much pollution? Is your environment downstream covered in litter? Do your neighbors complain? Does your cleaning contractor whinge? Are you paying for maintenance but removing little pollution? Are the screens of your device always blocked? Is your device affected by backwater? Have you seen your device fully pumped out? Did council accept handover of the device sight unseen? Did you answer yes? Then there could be opportunities to upgrade your device. Some GPTs are simply better than others, but older devices can benefit from rectifications. Pollution capture can be improved. Pollution retention can be improved. Pollutant storage can be increased and cleaning frequency decreased, which we'll use an example in this presentation, in this video. Construction faults can be rectified, maintenance access can be improved, cleaning can be made easier, work health and safety can be addressed, and complaints from the public addressed. So, typically, in summary, 90% of GPTs can be improved. Just because it's a low-performing device now doesn't mean council is stuck with that poor lemon solution for the next 50 years. Regarding bang for your buck, you can double the performance of 10 existing GPTs for the same price as a single new one. That's 5 times environmental outcome for the same dollars. So, moving on. First one up here is the old basket, old technology. So, typically these baskets, GPTs have been decommissioned by lots of different councils. There's several reasons for this, performance, lack of equipment, and as you can just see here, it's just old technology. So major reasons for some GPT failures can be structural, hydraulic, improper technology, human design, maintenance. Here we go, moving on to the CDS GPT, one of the more popular GPTs around the world. And as you can see here, it actually has a basket inside it. And this is a typical case with a lot of the older style CDS GPTs. Here we are looking down at the the surface plus the basket in there on the chains. But problem with this basket is that it affects the hydraulics of the device and it's very difficult to clean, and you don't clean behind the screens. Look what's going to happen to this. Completely full behind the screens. This GPT is ineffective, not doing anything. Council may be paying good money after bad. And looking further behind the screens, this is what you want to avoid happening. If you have a basket and you're not cleaning underneath it and behind the screens, you don't have a cleaning specification, this is what can occur. And this is an example of what exactly has occurred. This pollution absolutely devastated this GPT. Screens eaten away, damaged, sitting in an anaerobic environment. Wasn't cleaned behind the screens ever. So therefore, the pollution ate away at the screens and bad, real bad. But good news, Optimal Stormwater came in and we designed and installed the new screens to bring this GPT back to life, which is exactly what you want to be happening. There's a really important relationship between weir height, screening area, screen height, pollution storage volume, and the diversion chamber of the GPT. So this is an important example of a collapsible weir. This one example was collapsed down, couldn't get it to move. But if it was designed to be collapsed up the whole time, how does that affect the height of the screens that it was designed for? And what can you do to improve your GPT to get better storage and hydraulics? This is going to move through some examples of some weirs. This is a GPT with no weir. Haha, it was doing nothing. Here are an example of a GPT with a low weir. This is also doing nothing. Looking closer at this, it's basically professional negligence that the pollution goes in and goes straight out again. This GPT not doing what it was designed to do. Here we have again another GPT the weir was cut down, it was way too low, wasn't performing, pollution went in, straight out again, doing basically nothing. This is a good example of an upgraded one, which we can show you in the future. Here we go, again, another open channel GPT, very large one, but the weir was too low, losing all pollution. And if the weir is going to be that low, it doesn't need all the extra screening area, but it has a massive catchment and there's really great opportunities to get more pollution capture, as that can be more important than pollution screening. Here we go, one of the largest GPTs in the world, but the weir was too low. It wasn't effective enough to drive the device. The water wasn't getting enough vortex action happening. The weir needed to be the height indicated here for proper pollution removal. Then we go to the opposite problem, GPTs with weirs too high. Looking further back up the pipe of this one, this weir was way too high. Number one rule of GPTs, don't flood anyone. And if you have a weir that high, do you even need, is needed? Is it hindering maintenance? Can it be cut down? Here we go, an example, one of the larger GPTs out there with collapsible weirs. And this is quite a famous one. You can see the weirs, both of them are actually stuck down, and this GPT, pollution going in, straight out again. But good thing about this, at least there's a drop board there for the inlet, but there's not one on the outlet. The massive improvements could really improve this device. So let's move on to the GPT rectification solutions. Here we are, collapsible weir. Best thing is demolition, demolition, demolition. And what do you end up with after that? Nice, beautiful, new concrete curved weir, exactly as it was designed to do. Really good hydraulics there, pushing the pollution into the device. So, solutions. His GPT, the weir was way too low. What we can do, just put in a stainless steel weir extension, bring this weir height up to the height it needs, and not lose pollution out of the device. It was human design, really important factor. Again, this GPT here had quite a high weir, but human factor didn't consider the tide. Tide would just go in, wash all the floatables straight out again over the top of the weir and out again. So we've manufactured and installed this weir, problem solved, pollution now is not lost from it. Again, a similar situation here. The GPT was originally designed with the weir height too low for various reasons. So, and pollution will get lost with the tide. So we've come in, rectified it, increased the weir height to what it should be, and also added nice exclusion bars there. Again, another height. This is an example of a backwater from a wetland GPT, and the wetland backwater was causing an effect on the GPT's performance. So put in a stainless steel weir raising to increase the pollution capture, really important upstream of a WUSD device. Here we have one of the typical, the most underperforming GPT there, the Ecosol GPT, and you can see there straight away the weirs are way too low. Pollution goes in, going to get sucked straight out again over the top of the weirs. So rectification, pretty simple. I don't know why they didn't do this in the first place. We just put in stainless steel weir extensions to the correct height to match the device so that when pollution goes in, it is actually retained and not lost, as is most common with your standard average Ecosol GPTs. Here we go, another custom GPT, but again, weir height was too low. Pollution would get lost, sucked out again. So what we did, came across, put in a new stainless steel weir to the correct height so that you could drive the correct amount of flow into the GPT, not lose pollution. Another solution you can come up with is when you have backwater, either be it from wetland, bioretention, or even a pond or the ocean, is to put in a secondary weir at the outlet of the GPTs. That way, when you go to clean it, you're not sucking out the entire pond, wetland, lake, or ocean. And here we go to the situation of the deep weirs that are too high. And this one, the weir was cut down, and this is to reduce the hydraulic effects. Again, the weir was put in too high back in the old days, old technology, human design. And this is the exact example we're going to be moving to. So the weir was cut down in this one. And this example, it was, here we go, 2.8 meters of screening area on this GPT, but the weir height had to be cut down, so rendering those excess screen areas useless, not needed anymore. And this GPT had the old sump and was becoming a real problem with such a large catchment, small storage volume, that had to be cleaned so frequently, pollution caught behind the screen. So here's our rectification solution. What we came in and did was we added additional sump storage areas by removing screen panel and putting perforated plate. And you'll see a video on this. This image is a bit complicated because the install by another contractor was done wrong, but you'll be able to see this in there. But to highlight the areas we're talking about is you've got the additional storage area highlighted here. And this is a great way to repurpose this GPT back into life. And for all you Stormies out there, here is some technical details on the design. This was the existing before. And here we go, the rectification afterwards. So we've tripled the pollution stump volume so that council can decrease the cleaning required, increase the amount of environmental pollution removed for the environment, and reduce the overall long-term operation maintenance costs to council. So let's watch the video.
Okay, so we are inside the newly converted 2018 at Hamilton Lane in North Sydney. Previous contractor has come down to increase the capacity for the sump, which is really good and seems to be working well. As you can see inside, perforated plate. The only problem is we have a screen breach here, which has been, the screen has been ripped due to pressure.
Oh my God! Hey! Huh?